So we've talked about whether or not we can reject or not reject a hypothesis, and we've talked about the type of errors we can have. And what we want to talk about when we talk about effect size is we really want to talk about if we do detect an effect of a treatment. So we've rejected our null hypothesis. We're saying, yes, my sample is different from my population, or my sample is different from my control group. Now I want to know how much of an effect did it have. Was it a small? Was it a medium? Was it a large? So that's what we're going to talk about when we talk about effect sizes. So in research, we shouldn't just say that there was an effect. We want to try to say how much of an effect there was. So that's what we're going to talk about in this one. So we're going to do a calculation that's intended to measure the magnitude of the effect. So again, we can talk about a small effect, a medium effect, and a large effect. So when we do this, though, we want to make sure you're understanding we are comparing two different groups. So we can compare a control group against an experimental group. So remember, when we talk about a control group, that means it's a sample from my population in which they did not receive the treatment, whereas my other sample from my population received whatever treatment I was looking at. So for example, if I'm trying to determine the effects of a therapy on a treating depression, I would have an experimental group that got the therapy and a control group that did not, or we maintained status quo on therapy. So if I'm trying to determine if a new therapy is more effective. So I could determine the effect size, small, medium, large, on depression that my new therapy had, if I detected there was a difference between them. So remember, this is like an extra step after I've already said, yes, there is a difference between my two groups or my population. Now I want to see how much of a difference there was. So we're going to calculate the effect size. So we calculate it, what's called Cohen's d. We do the mean difference divided by the standard deviation. So we do the mean of the treatment group, the mean of the control group, we subtract them, and then we divide by our standard deviation. A d of 1 indicates that the groups differ by 1 standard deviation. Again, a d of 2 would indicate that they differ by 2 standard deviations, and so on and so forth. Now, I want you to understand, I'm not talking about them differing from the mean, I'm talking about them differing from each other. Okay, so since we're talking about the treatment versus the non-treatment, we're talking about how many standard deviations they are away from each other based on the population's standard deviation. So when we have that, we talk about the magnitude of d. So if d is equal to 0.2, we would consider that a small effect. Okay, and again, remember that we're doing this Cohen's d after we've already said there was an effect. Okay, so we know that there was something happened. We know that the two populations were different from each other, or the two samples were different. Now we're just trying to figure out how different they were. So we get again, a 0.2 would be a small effect. By the way, if I got a d of 0, that would be no effect, okay? A d of 0.5 would be a medium effect, and the large would be 0.8, or anything larger than that would be a large effect. So if we had an example and said there was a study, a known population where a normal distribution was a mu of 50 and a standard deviation of 5, what is the effect size if a researcher predicts that given an experimental treatment, they would have a mean of A, 50, B, 51, C, 54, D, 56, or E, 47? So we're going to go through all 5 of these and show the effect size of each one of these. So again, we're going to do the mean differences divided by the standard deviation. So for the first one, for A, we would have the A, which was 50, minus 50 divided by 5. So this would end up being, there was no effect. Okay, remember, if I have a 0, that means that there wasn't any effect, which probably means that if I were actually to run my statistical analysis on this, I would tell you off the bat that I would not reject the null hypothesis because there's no difference between these two groups. So let's do for B, which is 51. So I do 51 minus 50. So I get 1 over 5, or 0.2. That would be a small effect according to my chart on the previous slide. So now let's do C. So this is 54 minus 50. over 5, so that would be 4 over 5, or 0.8, and that would be a large effect according to my chart. So remember, 0.2 was my small effect, 0.5 was my medium, and 0.8 was my large effect. So we'll continue on with part D. Again, we're doing our mean of our differences, so we're going to do 56 minus 50, which would give us 6 over 5, or 1.2. Again, that would be a large effect. And then the last one, we're doing 47 minus 50 divided by 5, which would be negative 3 divided by 5, which would be a negative 0.6. Even though it's negative, we're not really concerned too much with the positive and negative when we're talking about effect. We're more concerned with the number itself. So kind of ignore the negative on these, and you would say that that had a medium effect because of the 0.6. If you have any questions on how to find the effect size, please make sure to email me and let me know.